Welcome to my channel. This is Physical Science Time. This time I will be showing you on how to identify the limiting reactants and the excess reactants in a certain chemical equation. Alright. Limiting reactants are the reactants that are completely used up. It determines the maximum amount of product that can be formed in a reaction. Excess reactants are the reactants that remains after the reaction has stopped. Okay, we have a sample problem. How much carbon dioxide will produce of 1 mole of methane and 3 moles of dioxide of carbon dioxide from the ratio of 1 CH4 is to 1 CO2 for the reactants, and for the products are 202 is to 1 CO2. Okay, next. 1 mole of CH4 times 1 mole CO2 over 1 mole of CH4. So, we get 1 mole from the coefficient of CH4, and we get also 1 mole of CO2 from the coefficient of CO2, which is 1. So, divided by 1 mole of CH4. So this time we have to cancel this 1 mole CH4 here, and same as here, 1 mole CH4 here, cancel this. What is left is the 1 mole carbon dioxide over 1. That is equivalent to 1 mole of carbon dioxide. Okay, next. 3 mole dioxide times 1 mole of carbon dioxide divided by 2 mole of dioxide. So we get 3 moles from here, while we get 2 moles of dioxide from the coefficient of dioxide here. Okay, so 3 divided by 2, that is 1.5 mole of carbon dioxide. Okay, next. Conversion of mass in grams into moles. Sample problem. How many moles are there in 162 gram of calcium chloride? Okay, step 1, we have to calculate the molar mass of calcium chloride from the periodic table. Okay, as you can see that our calcium has 40.08 molar mass, while the chlorine has 35.453 molar mass. Okay, here, since calcium has 40.08 and chlorine has 35.453, we have to round it off. 40.01 times 1 equals to 40.1, while 35.5, we round up this for 35.453 into 35.5 times 2, that is 71.0. So where did we get 1 and 2? So we get 1 from the subscript of calcium, which is understood to have 1, while 2, we get this from the subscript of chlorine, which is 2. Okay, so 111.1 gram per mole. So 162 gram calcium chloride times 1 mole calcium chloride divided by 111.1 grams. So we have to cancel grams here and also here. So what is left is 162.5 mole calcium chloride divided by 111.1 to give us 1.5. So meaning, in every 162.5 gram of calcium chloride, there is only 1.5 moles of calcium chloride. So we have already converted from grams into mole. Alright, next. Calculating limiting reactant and excess reactant using a balanced chemical equation and mass ratio. Okay, Sodium hydroxide reacts with phosphoric acid to form sodium phosphate plus water by the reaction of 3 sodium hydroxide plus phosphoric acid. This is our reactants, and our products are the sodium phosphate plus water. So we will check if this equation is balanced. So sodium here has a coefficient of 3, so meaning sodium has 3 atoms in the reactants, while in the products sodium has a coefficient of, to have understood, a coefficient of 1 times the subscript of 3, that is equivalent to 3. So meaning our sodium has 3 atoms both in the reactants and in the products. So next we have also to check the number of atoms of oxygen, of hydrogen, phosphorus from the reactants and in the products. But this is already balanced. If you try to check it later on, I assure you that this is already balanced. Okay, to maximize our time, we have to proceed. So if 35.60 grams of sodium hydroxide is reacted with 30.80 grams of phosphoric acid, how many grams of sodium phosphate are formed? What is the limiting reactant? How many grams of the excess reactant remains? Okay, we have to solve these problems. Okay, again we have to refer it from our periodic table, since again we will be calculating the molar masses of the compounds. Okay, the molar mass of sodium hydroxide, okay, as you can see that sodium has 22.9898, the oxygen has 15.9994, while hydrogen has 1.00797. Add these 3 molar masses to give us 39.997 or 40 grams. So the phosphoric acid has also 98 grams of molar mass, while the molar mass of sodium phosphate is 163.94. So you know how to solve or how to calculate this molar mass, right? So congrats for that. So next time, next we will proceed. Okay, sodium phosphate formed from sodium hydroxide. So 35.60 grams of sodium hydroxide times 1 mole of sodium hydroxide divided by 40 grams of sodium hydroxide. 35.60, this is coming from in our problem, while this 1 mole of sodium hydroxide, we get 1 mole since our sodium hydroxide here, this one, sodium hydroxide has a coefficient of 1. So we have 1 mole here of sodium hydroxide divided by 40 grams of sodium hydroxide. 40 grams is the molar mass of sodium hydroxide. So this is equivalent to 0.89. So times 1 mole of sodium phosphate. 1 mole, since our sodium phosphate here has a coefficient of 1, divided by 3 mole of sodium hydroxide. 3 moles since we have here the subscript of sodium is 3. So 3 mole sodium hydroxide times 163.94 grams. This is the molar mass of sodium phosphate. Now to give us 48.64 mole of sodium phosphate. So total 48 0.64 grams of sodium phosphate. Alright, next. Sodium phosphate formed from phosphoric acid. So we have this 30.80 grams. This is given. Phosphoric acid times 1 mole phosphoric acid. We get 1 mole since phosphoric acid here has a coefficient of 1, divided by 98 grams of phosphoric acid. 98 grams is the molar mass of phosphoric acid. It is equals to 0.31428 times 1 mole of sodium phosphate. Again, our sodium phosphate has a coefficient of 1, that's why we have 1 mole, divided by 1 mole of phosphoric acid times 163.94 grams of sodium phosphate. This is the molar mass of sodium phosphate, to give us 51.52 mole or per mole of sodium phosphate. So total 51.52 grams. So when 35.60 grams of sodium hydroxide is reacted with 30.80 gram of phosphoric acid at about 48.64 grams of sodium phosphate are formed. The limiting reactant was the sodium hydroxide. Okay, since sodium hydroxide has the smallest amount. Alright, so how many grams of excess reactant remains when the reaction is complete? Okay, this time we have to compute the excess reactant or the excess phosphoric acid. Okay, 48.64 grams sodium phosphate times 1 mole sodium phosphate divided by 163.94 grams of sodium phosphate, which is equals to 0.29669. Then multiply this by 1 mole of phosphoric acid divided by 1 mole of sodium phosphate to have 0.29669, divided it by 1 mole of phosphoric acid times 98 grams of phosphoric acid to give us 29.0. So since we have this amount, we can now subtract this from the 30.80 grams which is already given. So 30.80 grams minus 29.08, which is equals to 1.72 grams of phosphoric acid. So this is now the remain phosphoric acid as the reaction is complete. Alright, I hope that you got everything. I hope that you listen very well. Thank you, and once again, thank you, and bye bye. Bye bye.